Hey guys, welcome back. Now that we've established that a Cisco router, specifically a Cisco router, is a key essential component of networking. Why is it a key component of networking? Because the whole objective of networking is to connect different networks to each other. And the component, the device that makes that possible is this device known as a router. So in this particular video, my objective over here is to show you what a router looks like, try to compare it to a PC, take a look at the different components that you have in terms of the hardware like RAM, storage. We'll take a look at those. Then we'll take a look at how do I configure it, because a router does not come with a monitor or does not come with a keyboard. How do you actually put the commands on a router? We'll be taking a look at the configuration components of a router. Once we're done talking about the configuration of your router, the configuration components of the router, we'll be taking a look at another very important part of the router, which is the interface. The whole objective of a router is to connect different networks to each other. And in order for the router to connect up to the networks, it needs the interfaces. The interfaces are what we'll take a look at next. Those are another very important component of the router. Once that's done, we'll take a look at the boot up sequence of a router. How does a router boot up? Uh, just like on a PC, it does have certain steps that it goes through to boot up the device, just like a PC is booted up. We'll take a look at the steps to boot up a router. And the last but not the least, we'll take a look at how do you configure the router. What are the different software components to configure the router? What are the modes that you go to configure the router? All right. With that in mind, let's get started with it. The first thing is the router hardware. Let me give you an overview of the router hardware, and then we'll take a look at the slideshow. The router is made up of four important hardware components that we need to be aware of. And as we go through it, we will try to compare it with a normal PC. The first component is called ROM, read-only memory. This is a chipset that comes built in with two essential components. One is called a bootstrap program. This bootstrap program is responsible for going through the sequence before the actual operating system is loaded into memory, RAM, because the operating system is run from RAM, which is exactly the same way that your normal PC would boot up. Normal PC would also have the bootstrap program in ROM. It loads up the bootstrap program as soon as it comes up. Once the bootstrap program is loaded up, it loads the operating system of a PC, which is your Windows operating system or a Linux operating system, whatever operating system you're running on the device. Similarly, on a Cisco router in ROM, you have the bootstrap program, which is responsible for conducting certain hardware tests on the device, the router itself. And once those tests are done, it will look up the operating system, load the operating system up, and say goodbye, all over to you, operating system. Besides that, it also has another small component called the mini operating system, mini OS, also loaded up in this read-only memory. This is used in case of a disaster. Let's say your main operating system is blown away from storage and you want to recover the router. So when the device tries to boot up, it does not find an operating system, it hangs. The mini operating system is loaded in that case, so it gives you base essential components so that you can load up an operating system on this device where you have had a disaster with your operating system which has been lost and you're recovering it. So the mini IOS is used for that. Okay, so that's the first component, that is called the ROM, the read-only memory. The other component is just like you have on a PC, which is called RAM. This is your work area. Just like on a PC, when the operating system is loaded up, to run the operating system, you load it up into random access memory. This is the volatile part of the memory where whatever was inside or was being used in RAM, if you lose power to the device, you lose all the work over there. So you need to have that work saved somewhere, like the operating system saved somewhere, your configuration saved somewhere, because this is just a work area where you run the program. Just like you run a word processing program on your PC, in there you write a letter. If you haven't saved the letter and you lose power to the PC, the letter that was being written in RAM is lost. The program that is running is also loaded into memory to be able to run it. So anything that needs to run, it goes into RAM. The third component is the storage component. The first storage component, there are two storage components. The first storage component is called the flash. This is a storage component that is used to store the operating system file. On a Cisco router, the Cisco router uses the operating system called the internetwork operating system. This is the operating system that Cisco programs or creates. Just like Windows is created by Microsoft, iOS is created by Cisco. The router's operating system is called the iOS. So the iOS is stored on flash. It's not run from flash, it's stored over there. So when the Bootstrap program comes up, it gets loaded into memory. Its job over here is to locate the iOS in where? In flash. Once it locates it, it loads the flash into memory. That loading up of the iOS file into memory is done by the Bootstrap program. Once the Bootstrap program loads the iOS, it hands over control to the iOS, takes a back seat. But the actual location of your iOS, the operating system, is in flash. That's like your hard drive. So your operating system is stored inside your hard drive, but the Bootstrap program initially would do what? It would have loaded up that operating system into memory, and it's run from memory over there. All right, that's the location of your operating system. Similarly, you have another component called NVRAM, which is non-volatile RAM. Non-volatile RAM, as the name suggests, it will not be lost in case you lose power to the device. The function of the non-volatile memory is to store not the operating system but the configuration file. All the configuration that you do on a router, that might be assigning it an IP address, maybe running a routing protocol, all those configurations by default are run in memory. So as you're assigning an IP address to the device, it's done in memory. It's not stored by default. So what you do is, you as the administrator, once you're done with the configuration, will save, just like you save a word processing file or a spreadsheet, you save the file and you save the file to NVRAM. The name of the file on NVRAM that is stored is called the startup config file. So whatever configuration is done, you save it to your NVRAM. The name of the file is called startup config. So now let's go back to the sequence of booting this device up. Is when the Bootstrap program comes up, gets loaded into memory, it will look for the iOS file on flash, load it up into memory, run it. Once the iOS is run, iOS will go ahead and take a look at what? The startup config file inside NVRAM, load the configurations up so that the configurations of the previous time before the router rebooted are still preserved. If you do not save your configurations over here, let's say you do configure the router and you don't save it, because by default it doesn't save it. So if you don't save your configurations and the router loses power and reboots, guess what? When it comes back up, there's no configuration file by default, so it's going to be a blank config. So you would need to reconfigure the router from scratch. So those are your four main components of a device. Now that we've talked about it, now you have an idea about it, let's go ahead and take a look at your slide over here. So the first thing, as I said, was router hardware. We took a look at the four components. Let's do a recap. Read-only memory, this is the one that contains the Bootstrap program, the two components over here. One is the Bootstrap program, and the other one is the mini iOS in case of a corrupted OS and you want to recover. This is used for recovery. RAM is basically your work area. This is where the operating system or any other components related to operating system are loaded so that you can run it. So that is the work area, just like you have on a PC. This is very similar to a PC. Now, flash. What does flash contain? Flash is the location of the operating system. What is the name of the operating system on a Cisco router? It's called the Inter-Network Operating System, or popularly known as the iOS. The iOS is stored in flash, so when the Bootstrap program loads up the iOS into memory, iOS then is run. But where is the iOS stored at? It is stored inside your flash. So it's taken from flash, loaded into memory so it can be run. All right, so flash is the location of your operating system file. It is also used to store other files. As we go through the program, I'll explain some other files that you can also store on your flash. But the main purpose of flash is to store your iOS. The last component that we discussed was the NVRAM. What was the NVRAM used for? The NVRAM is used for the storage of your configuration file. What is the name of the configuration file? The configuration file name on a Cisco router is called the startup config. All right. When initially the router boots up, it will locate the startup config file in NVRAM. Looks for the file called startup config. Finds it, loads it up into your RAM. As the administrator, you work with the file in RAM. The file, when the startup config file is loaded into memory, it's called the running config. As you go through during the day or during the uptime of the router and you start configuring the device, all the configuration changes that are being done that you're doing are done to the running config. They're not done to the startup config. It's imperative whatever configuration changes that you've done over here, what do you do with them? You save them back to where? To the startup config, so that they're there in case something happens to the router, it reloads, or you have to bring the router down for maintenance, or you lost power, so that the next time it comes up, all the changes that you made to the running config are stored in your startup config for the next reload. So again, when the iOS loads up, it will locate the startup config file, load all the configurations from the previous load into RAM. You make changes to this file in RAM called the running config. Initially, it's a copy of the startup config, but then as you make changes, it becomes a little different. Then if you want those changes to be there the next time around, you save it. I'll show you how to save it as well, the startup config file. Now, what if you did not save it? You lost all the configuration changes. Let's say you never saved the startup config file. When the router boots up, it will boot up with the default configuration, which is essentially blank. All right, so it's essential that you keep on saving your configuration file on a regular basis, which is not done by default. So these are the first four components of your router, the router hardware. Besides that, the next thing that we need to take a look at is the configuration aspect of it. Now, configuration of a router. Unlike a PC, which has a video monitor and a corresponding keyboard, the router does not have these two components. So how do I actually go in and type in the commands, the configuration commands for the router? What they've done is they have given you a special type of port to configure it. This port is called the console port. Console port is a RJ45 type of jack. This cable is known as a rollover cable, which on the other end used to have the DB9 connector, which is the old serial connector, which would only go into a PC that had a DB9 connector on the other side as well. So if a PC had a DB9 connector, you would connect it up. On the PC, you would load up a program like Hyperterminal. The older Microsoft Windows used to come with this Hyperterminal program. Or you can use a program from the internet called PuTTY. Or you can use another program which is very popular, which I use a lot, Secure CRT. I can use any of these programs to connect up or use my DB9 port, which was also known as a serial port on a PC to connect to the console. As soon as I did that, I launched my PuTTY program and told it to use my serial port. I would get access to the router. So any commands that I put in PuTTY were actually being done over here in my running config. And at that time, I would also use a special command to save the running config to your startup config. Okay, so all those commands would go on to the PuTTY, hyperterminal, secure CRD programs, but they were actually, although I was typing it on my keyboard over here on the PC, they're being done to your running config on your router. All right, now the problem over here was not a lot of new PCs have the DB9 connector. So you have two options. Option number one, you get a converter, an adapter that would allow you to connect the DB9 connector to a connector which on the other side had a USB connector, which is a more prevalent connector on today's PC. Using the same program but using a connector that would be a DB9 type of connector on one side and USB on the other side. Or now you can also get cables, your rollover cable, which does not have a DB9 connector. Instead, it directly comes with a USB connector. All right, so that was the other way of doing the connection of a router through the console port, and this had to be done upfront. So this is the only way to initially configure the router through the console port. Okay, once the console port would configure it, then you could take it to the next level and configure it remotely using the other options. But the first option was always the console port on the router. All right, let's take a look at the first configuration source, which was the console port. So every device had a console port. Just to give you an idea, this is your console port on the router, generally in this cyan color. It would be labeled as console. This is a typical rollover cable, which had RJ45 on one side, DB9 on the other, but it required your PC to have a DB9 connector. If you did not have a DB9 connector, you would get an adapter like that, which had the DB9 connector on one side, USB on the other side. The USB would go into your PC. Or what was the other option that I told you also had? You can get a cable that has USB as the connector connecting to RJ45. That was the third way to do it. But as I said, initially the first configuration would always be done through what? Through the console port, and then you could assign it an IP address, or you could connect or configure this other port that we'll talk about right now called the auxiliary port or the aux port for remote connection through the modem. We'll take a look at that next. So this was the first one, and the initial configuration was always done through the console port. What are the other ports that you can also do the configuration from? The other port is a physical port again. It is called the aux port. This nowadays is not being used that much, and some of the devices don't even have this port. The aux port was an older mechanism in which I could use a device called the modem. Why? Because I wanted to remotely configure the router through the modem, which would connect up to my normal wall jack, my phone line, through my PSTN, which is my normal phone network, and I would be sitting on my PC at home using a modem. I would dial the number over here that is associated with this wall jack, normal number, connect my modem to my PC, dial the number, get access through the modem to the router console. So that was the aux port. That was the functionality of the aux port. As I said, nowadays nobody uses that. Why? Because everyone has a connection, an IP-based connection to the internet. So rather than using this extra device, going through this extra hassle, a lot of the people choose to use IP addresses and get access through the internet using an IP address to connect up to the virtual port. This is not a physical port, this is a virtual port. We'll discuss this next. This is also called a virtual line, virtual terminal line. So I would connect them from the PC to the PC through the internet using IP as a protocol to do remote configuration. So aux is not being used as often. It's not as popular. Some of the devices don't even have this port. So Cisco devices also have an aux port or an auxiliary port or an aux port. Initially was used by the modem to remotely access your Cisco device. Nowadays it's not very common. So what's the other common mechanism? The one that is used a lot? Actually, this is the most common mechanism to configure a device, which is your virtual terminal lines. I alluded to that in the previous drawing that I did. So again, I have the internet. My router is being used to connect up to the internet anyways. Okay, it has an IP address assigned to it. Now my administrator sitting at home, he is also connected to the internet using his ISP. He also has an IP assigned to his PC. He can use IP to connect up into the router's physical port, the LAN port, and from there tell it using the same program, same PuTTY or secure CRT, to make a connection to the device to a virtual terminal line. The terminal line is the one that gives it access for management rather than passing data through it. I want to configure it, manage it, which is your virtual terminal lines, also known as the VTY lines. The protocol, the program that is used to communicate over IP for remote management through IP, there are two very common ones. Although this is the name of the program, within the program, the protocol, the communication mechanism that I use is either called Telnet or SSH. We'll actually do labs that I'll show you how Telnet and SSH allow me the ability to remotely manage what? The router using either one of those two protocols. Why is this the most common way of doing it? Generally, the router is sitting inside a data center, which is a very cold place, and it's generally stored in a secure area. So if I'm doing the configuration of the router, rather than physically going into the device or into that data center and configuring it, I can do it from the comfort of my office, my desk, or home, and be able to get the same things done remotely, which is more efficient to do. So initially, although you do configure the router through the console port initially, so that it can be assigned the IP address, Telnet or SSH can be configured. Once that's done, you save the configuration, move on to your desk, and start accessing the router for configuration remotely using the virtual terminal lines or the VTY lines. And that's my third configuration option. And this is the most common one. And again, as I said, this is not using a physical port like the console and the aux port have. It's a virtual line. So I'll use a virtual connection to make a connection into my router to be able to configure my device. As I said, this is the most common mechanism to do it because I can do it from the comfort of my desk. Although in order to do that, initially I do need to configure through the console port so that I can give it an IP address and configure Telnet or SSH. And as I said, the two protocols that are used commonly are Telnet and SSH. All right? That is your console port. So to recap so far what we have done, let's go back to my magical whiteboard. So I have a router over here. I'm going to make it a bigger component. So I talked about ROM that contains your bootstrap program. It also contains a mini iOS. We talked about RAM, the work area. We talked about your flash, the storage area for your iOS. And we talked about NVRAM, the storage area for your configuration file. How do I configure the router? The two physical ports that I have, the console port or the aux port. Console is the more common one. Initially, you configure it on the console. Aux is only if I want to do remote management through a modem. Not very commonly done. Console initially is done through that rollover cable. Physical connection is required to a PC or a laptop over here. The more common way of doing it is through those virtual lines. The red one is not your physical line, the VTY lines as they call, using a command or protocol by the name of what? Either Telnet or SSH, which I'll show you how to do. The only configuration ones that we don't use generally is the aux. The other two I'm going to actually demonstrate to you guys. All right, so this is what we have talked about so far. The next component that is going to be talked about is the router interfaces. As we've been seeing in our introduction videos, whenever I want to configure a router, the main purpose of the router is to connect networks to each other. So this is a typical example of a router connecting different networks in the same office to each other. So I have an Ethernet port over here which will go into the switch. Ethernet is the protocol that is used for the LAN segment, connecting to my access point, which connects me to the wireless PCs, or I connect to the switch on this side, which connects me to the wired PCs. The router has two Ethernet ports to connect what? These two LAN segments to each other. On the other side, it connects to the WAN side. The WAN is your wide area network to your ISP. The port you can use over here is a serial port. It's a special type of serial port that is used to transmit high-speed data. Now, nowadays, even the serial ports have been replaced by Ethernet ports over here because Ethernet has more speeds that you can use rather than the serial. Nowadays, even the routers use a Ethernet port towards the ISP. Although I'll show you both serial and Ethernet, these are the data interfaces. This is what the router is really used for, is passing data, connecting the different networks to each other. So these type of ports, those are the two main type of ports that you have on a router for data propagation. The ports that we saw so far, the console port, the aux port, it's not used by end users to pass data through it. It's used to configure the router, and it's generally used by the administrators of the network, whereas these ports are generally used by the end users to transmit data from what? From one network to the other. So again, as I said, the main functionality of the router is to connect networks to each other, and that's done by using these interfaces. Router generally has two types of main connections, LAN and WAN. LAN connection is generally done through Ethernet, whereas the WAN is done through a serial connection, although nowadays the WAN can also be done through the Ethernet. We'll also take a look at in the course at a special type of interface over here called a loopback. This is generally for teaching purposes, although it does have a specific use in terms of networking, as you will learn later on in later courses. And also in this course, a loopback interface is a logical interface. It is used for testing. So if I want to see how my router works, if I had 10 networks connected to it, I can create these logical virtual interfaces called loopbacks and give them different IPs, simulating as if this router had multiple interfaces or multiple networks connected to it. So we'll take a look at that as well in later videos over here. So router also has a testing interface known as loopback. This is not a real network. It's a fake network to fake and see if a router had so many networks on it, how would it fare? So we'll be using loopback networks a lot throughout this course and other courses to simulate larger networks by adding more loopback networks to simulate more networks. But the two main interfaces that you'll always see, the physical interfaces on the router, are these Ethernet interfaces, which are your LAN interfaces, and you'll see serial interfaces, which are your WAN interfaces. As I said, you could also replace this with Ethernet on the WAN side, which is very prevalent in today's networks. So those are your router interfaces. So we've taken a look at that as well. Now that we have taken a look at most of the physical components of a router, which is your RAM, ROM, flash, and NVRAM, we've taken a look at your console port, your aux port, we've taken a look at your Ethernet and your serial ports. Now let's go ahead and take a look at the sequence in which a router boots up. Once we're done with that, the only thing that will be left over are your configuration modes. So the router boot up sequence, what is that? The router boot up sequence is how does the router get loaded up? What are the different steps that take place for the router to boot up? We have gone through those steps, although I'll go into it a little bit more detail right now, but you must have a fair idea of how a router boots up. Let's take a look at it. Step number one, which we talked about, bootstrap program is loaded into memory, memory meaning RAM, from ROM. It's stored, the bootstrap program itself is stored where? is stored in ROM, and it's loaded up from ROM into what? Into RAM. So if I had to give you a pictorial depiction of it, so first thing, the bootstrap program, which is in ROM, gets loaded into RAM. Okay, once it goes into RAM, it does a test known as a power on self test to make sure all the hardware is okay. I have my memory is not corrupt, the interfaces are there, all those different things are done. Once that's done, the bootstrap program will next look for what? The operating system in flash. So looks for the iOS in flash. Again, what does it do with it? Loads it up into memory. As soon as it loads up the iOS in flash, it hands over the control and says, go take over. I'm done with my work. So the bootstrap's functionality is to look for the operating system in flash, load it up into memory, run it, and let go of it. Let it run, take over from that point on. Once the iOS is taken over, it's running, its first task is to look for what? The startup config file where? In NVRAM. If there is a startup config file in NVRAM, it is loaded up with the configurations of the previous time that the router is up, and the router is good to go. If it is not found, that means there is no startup config. There is a default version of the configuration file that the flash contains, which has basic things like, I'll give you a simple example of that. The host name, by default, if you don't set it of the router's name, by default is router. That's the default host name. It sets that up. All right. So it will load that default startup config file name into RAM. At that time, it'll also ask the administrator, would you like to go through an initial configuration wizard, which will allow the administrator to answer certain questions to configure it upfront. They're assuming that you, as the administrator, don't know too much about it, so they ease you into it by running a wizard. Personally, I don't advocate the use of this because it goes through every option that you can configure rather than only the ones that you want. So we'll be doing it manually as experts. Okay, so but that's the sequence that you have. Let's recap again. You look for the bootstrap program from ROM, load it up, do the post. Bootstrap locates the iOS in flash, finds it, loads it into memory, gives control over to the iOS. Once the iOS is running, it will take control over the router. It will look for the startup configuration file in NVRAM. If it finds it, loads it up, you're good to go. If it does not find it, it loads the default configuration and prompts the administrator for the initial configuration wizard. And at that point, you're good to go. All right? So this is your router boot up sequence. Now, once this is done, the next thing we're ready to do is start configuring the router. Now, at this point, although we'll go through this in detail, I just want to talk about 3 different main modes of configuration of your router. When you go into the router, you go into this mode called the user exec mode. This is the first mode that you get into. This is a mode that has a limited set of verification commands. This is not meant for a full-on administrator. Over here, you don't have access to all the commands of the iOS. Limited commands are available to you, and these commands are not commands that you can configure anything. These are commands just for what? Verification only. And that too, not all the commands. Let's say you have an assistant that's coming in. You don't want the assistant to screw up anything on the network. You give him this so that he can check for configurations and report to you, hey, this configuration was like this configuration was like that. So you can take a decision on it. Limited verification commands. So you give access to user exec mode to network assistants, network administrators' assistants, not the actual administrator. All right, that's the user exec mode. Now from there, the next mode that you go into is called the privilege exec mode. What is this mode? In this mode, you again can do mostly verifications. So you can do a lot of your verification commands, but all, not just limited, everything. And some configurations. Very few, but you can do some configurations over here, like you can set the date and time. Setting of the date and time is done in this privilege exec mode. So in this mode, whoever has access to the privilege exec mode has the ability to verify, can check any of the configurations, whereas this guy has limited commands, limited verification commands. Okay, he cannot or she cannot do all the commands that are there, even for verification. Forget about configuration. Verification also is limited for the use exec mode. Whereas privilege exec mode, you have access to all the verification commands and very small set of what? Configuration commands. What about all the other configuration commands? There's a special mode that is dedicated for the configuration commands, which is called the global configuration mode, or the config mode as they call it. This is the mode that you actually do all your configurations from. 99% of your configurations are done from the global configuration mode. All right, so when an administrator wants to configure something like the host name of the router, you want to do any type of configuration, your routing protocols, all of those configurations are done under the global configuration mode. Under the global configuration mode, you have sub modes. For example, if you want to configure the interfaces, you have an interface config mode, which is a sub mode of the global configuration mode. Similarly, you have another configuration mode for your routing protocols. We'll take a look at that as we go through the course. So as you go through, you'll take a look at, for doing different type of configurations, you have sub configuration modes, but all of them are sub configuration mode of this main configuration mode called the global configuration mode. So you enter into the interface configuration mode or the routing protocol configuration mode all through this global configuration mode. And I'll show you this step by step. How do you go into the global configuration mode? Where do you go into the global configuration mode from? And from the global configuration mode, how do you go into the interface config mode or the routing protocol config mode? I'll show you that in videos that are following up. But at this time, I want you guys to know there are three main modes: user exec, limited, verification commands. Privilege exec, all verification commands, but very few configuration commands. And then you have the global config mode, which is where you have access to all the configurations, including sub modes that do specific configurations for specific components of your router. All right, so my objective again for this video was to give you an overview of what are the different components that the router is made up of. Hopefully I have accomplished that. Let's do a review to see if you understand the things that we talked about. The first question over here in the review is the dash is stored in the flash. And what is that? If you're saying iOS, you are correct. The dash file is, we'll say, the dash file is stored on NVRAM. That's what I meant. And what is that file name called that is stored in NVRAM? Startup config. The initial configuration of the Cisco router / switch is done through what port? Again, if you're saying console, right answer. If not, go back, check the video. Remote configurations of the Cisco router switch is done through the virtual terminal lines. Using what protocols? I don't need you to answer that over here. But all I was looking for is virtual terminal line or VTY ports. The protocols that I'm using are Telnet or SSH. Dash locates the iOS in Flash and loads it into RAM. That is the Bootstrap program. This is from that section that we talked about, the boot up sequence. Most of the configuration commands are done in the global configuration mode. All right. So that is your router components, the hardware components and the configuration components. Hopefully this was a good introduction into the world of routing or routers. Hopefully see you next in the video that I'll show you how to do the actual console connections to be able to start configuring the devices. So what we talked about over here, we'll actually be implementing it in the coming videos. You guys have a good one. See you in the next video.